I'll do the talk in English because at Treeverse we have employees that are not speaking Hebrew. So we decided we do all our talks in English since we started hiring people who only speak other languages. So you probably heard Elon saying that people don't trust the data that they see in the UI, right? They want access to the raw data to make sure that what they're seeing is actually correct. So we kind of have a trust issue. And this is what I want to talk about. Data trust is a huge subject, so I'm going to talk about a small portion of it, but hopefully something that would bring you value. Okay, so a couple of months ago, we have a BI system. We are 25 people. We have Postgres with a few hundreds of thousands of rows, really nothing to write home about. And a few months ago, I was looking at a dashboard at a metric that is, it's supposed to be non-decreasing. What it counts is the number of active installations of our product. Just a minute, I have to breathe. It's a thing. You have to stand here to see this. So we were looking at this metric that is non-decreasing. It counts the number of installations from the beginning of the quarter. It means that if we saw something active, it would add up, right? But it would not decrease because it's just counting the number of active installations we've seen. So we were looking at it for one day, and it was 500, let's say. And the next day, it was 499. I immediately Slack Noi, our amazing BI analyst, and before I even hit the enter, she goes, yes, I saw that. The non-decreasing metric just decreased. But you won't believe what also happened. I took the query, and I queried the data for the result we got yesterday. I was expecting to get 500 so I can start to debug the problem. But what did I get? 499. So now we have a data issue or a bug that doesn't reproduce. Yay. 25 years ago, I would probably be very, very excited about that, maybe even upset. Today, it's just another day at the office, right? And this is what we want to tackle. This is me. I'm sure you've already read that. So I'm going to, as I said, talk about a narrow part of what data trust is. Two main issues. One would be, what is the data that I have? And where is it? And why do I have that data? Okay, so it's actually a question of metadata, right? The data is somewhere out there. And I want to understand aspects of where it is, why do I have it? For example, you sometimes need some domain expertise to understand the data. You would want to know how it was collected in order to analyze it in a smart way, right? Or you just want to find it because no one knows where it is. That also happens. So that is one issue that we want to talk about. And the other would be the fact that the data changes over time. And I'll try and convince you that even the past changes. We're going forward towards the future, but our past changes. And that makes everything extremely complicated. Those are the two things. And let's have a look at why we haven't tackled them so far. So actually we did like 30 years ago when everything was relational databases and warehouses, and you would use Oracle, and you would get tools from Oracle that tells you a lot about the schema and allow you to add quite a lot of metadata to explain the things that are going on within your warehouse. But then the amounts of data really, really grew, and here we can blame scale, definitely. And we lost the really basic things that we could do with data. So we were trying to survive. We had Hadoop, and we started getting issues with ingesting data. Kafka came in, not going to survey the entire history, but it took us quite some time to get back to a situation where we're actually capable of handling the amounts of data that we have through those horrible distributed systems that we need to manage. And we can now, in the last 3-4 years, go back to those questions, but with new tools. And this is what happened in the last 3-4 years. Some of the things you see here are much older than that, but they really took popularity or grew dramatically in the past 3 or 4 years. And that's because we were able to finally start looking at real intrinsic problems of data. We will look at some of those later. Okay, so first, what, where, and why is my data? The evolution that we saw with that started with a simple catalog, but as I said, we had one database, it held the data, there was a schema to that database, and we could add metadata to that schema to describe everything that we needed. Later on, we added external documentation because we also wanted to know more about our queries. Maybe we had several databases, so stuff became a bit more complex. We had to evolve to documentation systems that are not part of the database. Later than that, we decided that doing everything manually doesn't really make sense. And we started developing systems that would help us get the metadata automatically or semi-automatically from some of the systems that are holding data. Could be simpler with databases, could be more complex with object storages and other animals that we are all using. But the idea is to, as much as possible, get things automatically. And we have reached a point where everything could be automated, or at least allegedly could be automated. And we have even evolved to platforms that are connected to all our data sources. Again, a vision, a concept, systems that claim to be doing that. If you have tried them, you know that they're only starting, but this is the vision, connecting to all our data sources and not only to the data sources, and bringing us this information about what the data is that we have, where is it, and some additional metadata. Let's see how they do that, this additional metadata part. So what you have on the left-hand side is the systems that we have that those tools can actually integrate to. And on the right-hand side, the features that they would offer. This is not a real system. This is taking the features of many systems and giving you an idea of what an intelligence platform that started as a data catalog and evolved to such a platform could do for us. Okay, so we have the storage in the databases. We also have meta stores, right, for some of our data sources. Hive Metastore, for example, for either S3 or Hadoop systems. We have ETL tools that hold the queries. We have BI tools, again, queries. And we have other dynamic querying engines. So we want to analyze all that data. So not only the static data of the tables and the columns and the data types, but also dynamic data of the querying that we can do or that we actually do, in what frequency do we do it, and so on. And we use all that data to get the functionality on the other side. So let's see what we can get. First, we have the ability to search. And under the hood, there are pretty cool search engines that are running in some of those systems. Some of them are open source, and you can actually pick in and see. And we can then find, so the where question is now answered by a search. If we want to collaborate, if we want to make sure we're talking about the same data, it is now easier. We're looking at the same interface, so we can easily collaborate. Once we've found the data, we kind of want to feel it, right? The first thing you want to do when you find a data set that you don't know. So you want a preview of it, you can get it. You want maybe a representation, a visual representation of the data, maybe a scatter graph or a histogram or something that would give you some feel of what's in there. You can get that too. And then you can go deeper into lineage, so the relationships between the different data sets. That can help you understand what influences what within the very long pipeline of calculations that you do. It goes into manageability and governance, which I don't like, so I won't talk about a lot, but a system like that can also offer governance. It means permissions, access, detection of PII, and so on, all in the same interface, okay? And of course, you know who created the data set, who's the owner, maybe who is the domain expert, because you really don't understand why this metric was defined this way. It doesn't seem right. Eventually, if it's not in the text, you want to talk to someone and understand the considerations, you can have that information within the system. So this is mighty powerful. This is why there's a very strong trend in adopting such systems now. And there is quite a lot you can choose from. An interesting point is that a lot of those are based on open source. And we would see that later on with the transient issue as well. Those open source projects come from companies that had those issues way before we did. So clearly Uber, Facebook, Lyft, and LinkedIn felt those problems in 2010. They developed their own internal systems, then they opened them in open source, and now we are hitting those problems a decade after them, and we can enjoy the systems that they have developed. Some of the products here are also just regular enterprise software. Okay, to add to that, our data is transient. What do I mean by that? So I'm arguing that the past changes. It's a really very deep philosophical argument that I'm making. But for example, if data is late, if I look at the data set today, I see nulls. If I look at it tomorrow after some operational thing had worked, I would get actual values. You can see the price column here having nulls, and over there having values that arrived late. So what I knew about yesterday, today, and what I would know about yesterday, tomorrow, are not the same thing. So another example would be if we had mistakes. A lot of our data comes from operational systems. Sometimes people just type in the wrong thing. They realize that after a while, and they fix it. And then we have the past changing again, this time not from not having data to having data, but from having the wrong data to having, allegedly, the right data. That could happen several times. So this is where the trust issue comes in, right? And the last one is a case where we are running an algorithm or maybe a model, and we have results. And then we improve the model, and we want to run the new model on the entire data set. Let's say it goes 3 years back or 5 years back, because our customers need those results the best that they can be, and we simply update the data set. So we replace one version of reality as we estimated it yesterday with a different version of reality that we have estimated today. This could also happen to us several times. So are we all convinced data is transient and changes over time? Yes, great. So this is a huge problem, really, if you don't handle it. And we need really good tools that allow us to handle it so that we can get things to reproduce, just as a basic thing. We need other things as well, but first thing, we really need things to reproduce. So a great example of how helpful a database could be comes from Snowflake, where you can actually version a table and get the history of a table. It's limited in time, but still, you can access the data as it was in the last 3 months. And you can also access the results of your queries through that history, which is very cool. It pays, you have to pay, it's a thing. But it does work, and that allows us actually to get reproducibility. So if we want to see the result as it was 2 months ago, we simply call the table at that time, and we get the result. Okay, but what if we're not using a database? We are using an object storage, and we are putting our data in Parquet files, because it's cheap and it makes sense. And we still need to have some control over the transience of the data. So we have 3 data, what are called open table formats, that allow us to manage that. And it actually started with having an object storage that is immutable and data that is mutable, as we just convinced ourselves. And that required support that is better than just holding many versions of the same data set with a lot of duplications. So what those formats do is that they have the beginning of the data set at the point where you started using the format, and then they save deltas of changes. Those changes could either be additional data, or they could be changes that you've made to the data. And then you also have very good concurrency when you're accessing the data, because you can decide whether you compact that information that you have saved in deltas and create a new version of the data, or you keep on accessing the data as it was while you accumulate the changes, but you don't necessarily allow others to access them. On the way, it also gives you, again, limited in time, but time travel. So you can now see the versions of the data as it was at the window before you lost that information, if you have, when you compacted. There are differences between them, so what I'm saying is kind of correct for all of them, but also incorrect for all of them, but that's the general idea. So those started actually 2012, 2013, again from large organizations, as we said about catalogs, and in the past 2 years, became extremely popular and standard in most data lakes. So what's also interesting, just as making a point here, all open source. One of them was commercialized day one because it came out of Databricks. But the other two were open source projects for a very long time, and now both are backed by companies that were founded by the creators of the open source projects. And those companies provide a managed service of those formats together with a kind of a meta store. At least that's the guess. They're not really out there, so you have to be a closed beta user to really know what's under the hood there. So, but it's either good news or bad news, I'm not sure, but this is a very strong trend now. Okay. Let's look at another view of this that is not in the level of one table within the data source, because both Snowflake and the open table formats help you manage a table. But usually when we work, we don't just use one table or one data set. We use several, definitely in ML, and, but also in data analysis. And we want to make sure that when we manage the versions, we manage the versions of all those data sets together in a good way. So again, an interesting trend, data-centric AI. That would mean, instead of focusing on the process that the code goes through, let's bring tools that really focus on what is happening to our data within the process of developing a model. So those data-centric AI tools put a lot of emphasis on the relabeling and the recollecting, and hence the versioning of those data sets for the model. And then, of course, the model itself, the hyperparameters, everything else could also be considered as data, because it's data. So all that packaged together is a version of something that we want to version together so that we will be able to reproduce, when looking at a certain data set, the exact, and of course the model and the code, the exact same results. So we're not looking for one table, we're looking for actually a repository. So there are a lot of ML tools out there. There is a handful of ML tools that take this approach and hence bring this support of repositories in something that seems like a Git-like repository for your data. Other tools just give you Git for data, not really caring whether you're doing ML or you're doing other things with the data. It's just part of, or a wrap around the source of the data. So you can use it for anything that you want, but it would give you a repository, a Git-like repository over your data lake. So you have your S3 bucket, you have a set of data sets there, and you can actually make it behave like a Git repository. Again, those tools provide the same capabilities. They're less calling it that, but it allows you to look at the data sets as a repository and then version the entire repository together. Use logic like committing data, which gives you a stop point that you can always return to reproduce. What we see here is really a Git behavior, right? So those green dots are versions of the data. You can say those are commits to the repository. So we have in the main branch commits that are progressing over time. You can tag them, and then you can just go back to what your training set, labels, whatever you're holding there together, model and so on, together. You can go back to that commit and reproduce the entire thing. Now, you remember Noi from the beginning of the talk, so if she could only just go into the commit from yesterday and see the data and the query the way they looked yesterday, she would probably be able to reproduce the problem. Not 100%, but with very, very high probability, which would have been a relief because to this day, we don't know what happened. So this is how strong reproducibility is, and it's important for anyone who practices data. And also here we can have the logos, so we can see the data-centric MLOps. Forgive me if I have forgotten anyone, but those are the ones that I know. And on the other side, we can see the general Gits for data. Now, those are not competing. They're actually interchangeable, right? So you can, not interchangeable. So you can actually use them together, one on top of the other. If you have a Git for data over one of your data sources, and you are using an MLOps tool that is data-centric, you can simply use it over a branch or over the main of this Git for data that you are using. So if I have to sum it up, I would say we're lucky. We're lucky because we're almost over. Most of us are over the scale issues. So we do have good tools to analyze the data with very reasonable performance, and we have them managed probably by someone else, either a cloud provider or a company, so we can run that analysis. And we also have now tools that really deal with intrinsic problems of data. So I have presented here the data catalogs evolving into the discovery systems and the open table formats and the evolution towards Git for data. But there are, of course, also the data quality tools that are becoming platforms. There are the orchestration tools. And all those are tools that help us really concentrate about the work with the data and about being able to provide trusted data and high quality results. Thank you.